a base. I don't want to get too muddy on this, but natural log's base essentially is e, but you would never write it as natural log base e of x. It's base e is on the log side, okay? All it is log base e. So if we wanted to evaluate each one of these, so natural log of e, well, we could write that as log base e of e equals what? So if we want to change this to exponential form, this is saying e to the x equals e. Even though it's not written, you could think of this as really e to the first on the right. So we know x has to be equal to 1. So the natural log of e is equivalent to 1. And this is going to come into play. This is actually very helpful. Whenever you see natural log of e, all it's saying is if it's within multiplication, all you're saying is you're multiplying by 1. So if I had 5 times natural log of e, it's really 5 times 1, so it's just 5. If I wanted to think of natural log of e squared equals some x value, well, this would be, again, log base e of e squared equals x. So in exponential form, this would be e to the x equals e squared. The only way these are equivalent is if the exponents are the same. So this one, x has to be 2. So the second one you don't see as often where it's a form that you can work with, but that first one, natural log of e, is very useful. You will encounter that natural log of e, and there's no reason to be intimidated or distracted by it. You can automatically say, well, natural log of e is just 1, and so that makes it a lot easier for me. I don't have to mess with that. Second one was just kind of giving you extra practice writing from natural log to log form to exponential form. All right, so let's do a little practice simplifying. Like I said, all the properties that we had with logs hold true for natural logs, because again, a natural log is a log, it's just base e. So I know this exponent property, I could bring that up. So this would be natural log of 10 squared minus natural log of 25. Subtraction allows me to rewrite this with one single natural log on the outside of 10 squared, and 10 squared I'm just going to write it out as 100 rather than write it with the exponent. So 10 squared is 100. So this is natural log of 100 divided by 25. 100 divided by 25, I could do that. That's just 4. That's as far as I'm going to go. Okay, all I'm doing is simplifying. There's no equal sign in this. So I'm not trying to solve. This is simply simplifying, writing it as one natural log in simplest form. So in simplest form, if you have a number to an exponent, do it. If you have division of two numbers, do it. All right, oops. This next one, so we could have natural log of x cubed plus natural log of y squared minus natural log of 5. I'm just bringing all that up. Okay, and we are simplifying. So this is PEMDAS in the correct left to right direction. So I took care of my exponents. I don't have any multiplication or division. Next, I want to tackle the addition. So this piece right here, I'm going to write as one single natural log. x cubed times y squared, but then I still have this natural log of 5 going on. So I'm combining those first. That addition I have to do first. And then I have my subtraction. So as one single log, this would be x squared, y squared, divided by 5, and I'm done. Oh, thank you. Should be cubed. Now let's get into solving natural log equations. So now we will come up with a value for x. So what value of x makes this true? Natural log of what equals 2? Well, again, I know this is log base e of x equals 2. So e squared equals x. What is e again? Is e a number or is e a variable? E is a number, like pi is 3.14. What is e? Like 2.71, 2.72. E is a function on your calculator. So everybody put your calculator in your hand. Find that E button. Do E squared. And you should come up with 7.39. So everybody try that. Make sure they get 7.39 when they do E squared. Okay. This is another one. You have to be able to use your calculator. Come up with E squared.
Mr. Arby, is it the 2 capital E's?
Nope. Nope. It should be a lowercase e. Okay, is anybody not getting 7.39? Don't worry about what's going on outside. It's Michigan. Come on. You guys have been here long enough. It's all right. It'll be good. Your spring sports pictures, if you have pictures today like we do for golf, you'll have a nice snow globe background with it. Okay, so x is 7.39, and you could check it. If you want to do a quick check, you could say, okay, natural log of 7.39, and that will equal 2. So you can do a quick check on that. Solving a natural log, this second one here on the right side of the screen. So same properties, solving equations with logs. A natural log is still a log. We want to isolate that log or natural log. So to do that, we're going to divide by 2 on both sides first. So natural log of x plus 2 now equals 3. Okay, so we've seen a couple of these, so I'm going to not write down every little step. I know natural log is the same thing as log base e, so this is e cubed equals x plus 3. Yeah. I'm doing it wrong. Yeah, there we go. Let's say that didn't look right. So e cubed is equal to x plus 2. So we'd subtract 2 from both sides. So I have e cubed minus 2 equals x. All right, put your calculators back in your hand. Do e cubed minus 2. So do e cubed, get a number, subtract 2 from that. You should end up with 18.09. Make sure everybody's getting that. Okay, do e cubed, get a number, subtract 2.
I'm trying to figure out.
Okay, anybody's not getting 18.09, call me over. You need to be able to do this. If you can't use your calculator as a tool to answer the questions, you're in a bad spot. You're not going to be set up well for Friday. Okay, all right, so let's keep going. A few more slides. This one plus one more. Yep, I double checked before I said it. Solving an exponential equation. So 4e to the 2x plus 2 equals 16. So now we have this e in there, and we know that I have that tool in my toolkit that I know if I end up doing a natural log of e, that actually becomes 1. So that gets rid of my e right there, so that makes it a little bit easier. Same thing with exponents. We want to make sure we get the exponent alone. So the piece with the exponent, let's isolate that on one side. All right, order of operations, but now solving, we're going backwards. So I want to undo any subtraction. Nothing there. I want to undo any addition. So I'm going to subtract 2 first. So 4e to the 2x equals 14. I don't have any division, but I do have multiplication. So let's divide everything by 4. 14 divided by 4 is 3.5. So e to the 2x equals 3.5. All right, let's rewrite this in log form now. So this would be log base e of 3.5 equals 2x. But I know log base e is the same thing as natural log of 3.5 equals 2x. Natural log of 3.5, that's just a number. I want to solve for x, so I'm going to divide by 2, divide by 2. And so natural log of 3.5 divided by 2 is equal to x. Everybody do that in your calculator. Make sure you can do a natural log. You'll have that function on your calculator. Natural log of 3.5. Hit enter or put parentheses around it because you don't want the natural log of one quantity, 3.5 divided by 2. You want the natural log of 3.5, get that number, divide that number by 2. And you should end up with 0.63 is equal to x. So everybody do that. Make sure you get 0.63 when you do this. If you're not getting it, call me over because I want to look. Make sure we're doing it right. You need to be able to do this with your calculator. So second. So we're doing that long. So second gives you that green. So if you give these green letters, all right, so we should be getting 0.63. If you're not getting that, ask your neighbor or ask me. You need to make sure you're getting that. Okay, these are calculators that you have to be able to do this for the test Friday. If you're getting it wrong just because you don't know how to use your calculator, ask me. All right, and then the next one, e raised to the 3x minus 1 plus 5 equals 15. I'm going to get rid of this 5 first. Okay, so it's e raised to 3x minus 1 equals 10. And so if I rewrote this with logarithmic form, it would be log base e of 10, which is the same thing as natural log of 10, equals 3x minus 1. Again, we are solving for x, and we know natural log of 10 is just a number. So let's actually get a decimal on this before we get too caught up in. Let's get a decimal value for this natural log of 10 just to make things a little bit easier. Natural log of 10, we can put in our calculator, you should get 2.3 equals 3x minus 1. So this is basic algebra, solving a one variable equation. We would add 1 to both sides and then divide by 3. So 2.3 plus 1 divided by 3 would equal x. X would end up being 1.10, or just 1.1 is fine. Okay, last slide, Evan, promise. How long will it take an account that starts with $25,000 to reach 1 million if it is compounded continuously? Okay, continuously compounding. What was the formula for continuously compounding? That Pert. Okay, so it's compounded continuously at an interest rate of 12.5%. How long? So it's asking me to figure out what t is. So what is t? T, remember, is going to be in years. So I'm trying to figure out how many years it'll take. And so my function a of t is going to be my starting amount here, 25,000 times e raised to 0.125. So we're going to write that percentage as a decimal times t. And we know that final amount is going to be 1 million. So 1 million equals 25,000 times e raised to 0.125 t. So when we first started talking about this formula last week, I said guess and check. We did it graphically where we could graph 1 million, we could graph what's on the right, figure out where they intersect. Now we actually can solve these using natural logs. Okay, so first step, I want to isolate my piece with the exponent. So I'm going to divide this 25,000 out on both sides. This ends up being 40, which is a lot easier to work with. So 40 equals e raised to the 0.125 t. I can rewrite this in log form. So it'd be log base e of 40, or the same thing as natural log of 40, equals 0.125 t. So it's no longer in the exponent. Divide each side by 0.125, 0.125. T ends up being 29.51. And T we know is in years. So again, natural log of 40, that is a number. So be careful when you're putting it in your calculator. Make sure you are doing it as natural log of 40 divided by 0.125. That is not the same as natural log of 40 divided by 1.25. Do not do it how I have it written here on the right. Okay? It's only the natural log of 40, nothing with natural log of 0.125. So if you have to, in your calculator, you might want to put parentheses around this piece and then do the division, or simply do this, get a number, and then divide that number by 0.125. Because if you do it all as one step, you might accidentally write it and the calculator interprets it like this, which is not the correct answer. Okay, so a few homework problems for you to do. And then tomorrow we'll do some review.